All right, so this video is going to discuss the solution to the review question of number 16. Number 16 on the review has to do with an equilateral triangle that has positive charges at each one of the vertices, and they are all equal to 4 times 10 to the negative 6 coulombs. This is, again, an equilateral triangle, which is something obviously I cannot draw. But they are all 5 centimeters away from the other vertexes or vertices, and of course equilateral triangles have 60-degree angles. We have it labeled, this is being A, this is being C or B, and this is being C over here. So as we go through this, we are looking for the net force on charge number A, or charge letter A, excuse me. So if we draw a free body diagram for charge A, we'll see that first off it's going to have a repulsive force from B that's going to be going off at that direction. Okay, that's going to be the force of B. And then we also have a repulsive force going off this direction that is from C, as you can follow the line here. Um, Now, one of the things that we also need to realize is what the angles we have are giving us. And if this right here is a 60-degree angle, then so must this. That right there is a 60-degree angle. All right, and that's going to come into play here in a little bit. So first off, let's just go ahead and start calculating what FB is. So FB is going to be equal to K QA, QB, according to Coulomb's law, divided by the distance between them squared. So that's going to be 9 times 10 to the ninth times 4 times 10 to the negative 6. And we have another one. We could square it, but I'm just going to go ahead and write it out for consistency. Another 4 times 10 to the negative 6. And then all of this over. Now be careful, we're in centimeters, so this is going to be 0.05 and that squared. So when we put that into the calculator, we get 57.6. 57.6 newtons. All right, so that is FB. But if we really take a look at this, since all the charges are the exact same, FB must also equal FC. FC is not going to have anything different in there in terms of charges, in terms of distances. So this is equal to both FB and equal to FC. All right. Just a reminder that you can pause and go back at any time you need. So if we have this vector, and this is FC, and we need to add this to another vector that's doing basically the same thing but in the opposite direction, FB, there we go, and we're looking for that resultant vector. We know each one of them has a length or magnitude of 57.6 newtons. But how is this really going to help us at this point? Well, it turns out we're going to have to take a look at each of the individual components of these vectors. And you want to make sure that you pay close attention to the arrows that you're putting on these, because the directions of the arrows are going to make a lot of, um, uh, it's going to help out a lot as we get closer in. So we have these two vectors that we saw up here, and we are going to break them apart into their components. Well, according to similar angles and alternate interior and all this other stuff, that right here is going to be your 60-degree angle. Same thing over here. This is going to be your 60-degree angle. Now, if you find the component of one, it turns out that you're going to find the component of the other, mainly because we have the same hypotenuse and we have the same uh, angle. So one of the interesting things that happens is this x component and this x component. The x components on either of the two triangles are going to be exactly the same, but they're going to be going in opposite directions. So if we have one arrow going this way and one arrow going this way that are exactly the same length, when you add them together, you're going to get exactly 0. They're going to cancel each other out. So we really only have to worry about the y components of either side. And even then, all we have to do is calculate it once and then multiply it by 2, because the other side is going to have the exact same side to it. So as we go on, we're going to want to find this y component, and that's going to be, if we take a look at the 60-degree angle, that's going to be our opposite side, so it's going to be sine. So the y component, the force in the y direction, is going to be 57.6 newtons times the sine of 60 degrees. And when we put that into the calculator, we get 49.9 newtons. And if you want to, you could round that up to good old 50 newtons. All right, now I told you that we're going to have to actually multiply this by 2 because we have two of these vectors. So multiplying 50 by 2 gives you 100. So the final answer is going to be 100 newtons. This is the net force. It's going to be 100 newtons, and we need a direction. Well, if this is going up, this one component here is going up, and this one component here is going up, then we are going to have the same thing happening with our addition. So it's 100 newtons in the upward direction, or you can just say up, 100 newtons up. And that is the answer.